If you've ever tried to manually search the dark web, you know it is a deeply frustrating experience. The network is built on a series of independent onion relays, and if just one node drops offline, your connection breaks completely, forcing you to restart your entire intelligence gathering workflow. To solve this, threat researcher Apoorv built an open-source AI tool called Robin. Robin automates the Tor connection process, aggressively filters out dead links, and uses a language model to read and summarize actual threat intelligence for you. To run it, you'll need a Linux or Mac environment, or Windows running WSL. You will also need Docker installed on your host machine, alongside an API key for a language model like OpenAI, or a local instance of a llama. Before we touch the command line, we have to establish 3 strict operational rules. First, you must run a VPN at all times to mask your connection to Tor. Second, absolutely no searching for illegal marketplaces or illicit content. And third, never download any files from the results. These are mandatory constraints. Bypassing these basic guardrails takes you out of a controlled research environment and places you in immediate legal and operational jeopardy. Step 1 is making sure your host machine is ready. Open your terminal and verify that Docker is installed and actively running. You can check this by typing docker-version. Next, you need to install Tor. If you're on Linux or WSL, type sudo apt install Tor. For Mac users, the command is brew install Tor. Installing Tor directly onto your machine creates a secure gateway. This is what allows our AI tool to route its traffic deeply into the Onion network. Notice that we are not installing or launching the Tor browser. Robin doesn't need a front-end interface to work. It requires the underlying background service to route its requests. Running Tor silently as a background service lets the scraper operate anonymously on its own, keeping the messy reality of dark web traffic completely isolated from your main operating system. Now let's grab the actual tool. In your terminal, run a git clone command using the Robin repository URL to pull the code down to your local machine. Once the download finishes, type cd robin to navigate into the new directory so we can access the source files. Now we have to configure the API keys that power the tool's analytical functions. Make a copy of the provided .env.example file and rename that copy to just .env. Open that new .env file in a text editor like Nano. You'll see designated slots for different AI models. Choose your provider, whether that's OpenAI, Anthropic, or a local Llama URL, and paste your key into the corresponding line. If you skip this step or forget to rename the file, the tool's underlying logic completely fails. Without a key, Robin has no way to process the data it finds. Providing this API access is critical because Robin relies on multiple AI models firing simultaneously to read, filter, and summarize the sites it scrapes. In this context, the language model operates as a rigorous analytical engine, sorting through raw data to filter out law enforcement honeypots and dead ends. With our keys in place, we're ready to compile the tool. Run the command sudo docker build-t robin to start building the Docker container. This build process takes all the necessary web scraping utilities like Beautiful Soup and packages them alongside their dependencies into a single environment. When the build finishes, paste in the provided docker run command from the repository to boot up your newly compiled container. Watch the terminal output. You want to see Tor initializing and negotiating a connection until it completes its encrypted handshake with the dark web network. Keep in mind, this handshake takes time. If you try to force your way into the tool before the network connection stabilizes, you will generate a wall of errors. Running this inside a Docker container ensures that any highly volatile code or data you scrape from the dark web stays strictly sandboxed, far away from your primary operating system. Once the connection is stable, open your local web browser and navigate to localhost port 8501. This brings up the Robin web UI. Let's execute a test. In the search bar, enter a safe query, like ransomware, or your own email address to check for leaked data. The moment you hit enter, the AI steps in. It takes your basic prompt and rewrites it into a highly targeted threat query, optimized for dark web search engines. Then the scraping phase begins. Robin pings multiple hidden search engines simultaneously, pulling back hundreds of raw, unfiltered results, many of which lead to dead circuits or intermittent servers. From there, the AI evaluates the content of every result. It tests for live handshakes and parses text data, carving over 900 initial hits down to just 20 verified active Onion sites that contain actual intelligence. Manually verifying 900 links on a connection that breaks every few minutes would be a 6-hour marathon of rebuilding circuits and restarting browsers. By automating the verification and rejection of dead data, Robin condenses that entire workflow into a 30-minute session. After scraping those final 20 sites, Robin generates a clean, readable text summary of what it found, complete with recommended next steps for your investigation. You can click the download button to export this summary as a markdown file, making it easy to integrate into a local knowledge base like Obsidian. If you decide to take the links Robin provided and investigate them manually, your operational security has to be flawless. You cannot use your personal or corporate email. You have to build sock puppet accounts using burner phones and aliases that are completely detached from your real identity. Threat actors actively hunt for inconsistencies in new users. If you adopt a persona to infiltrate a forum, you have to maintain it. Survival in threat intelligence requires unwavering discipline, strict OPSEC, and never breaking character.